Hello students, what we're going to do now is have a quick review of functions and derivatives because we'll need this for the applications that are coming up shortly. So what I'm going to do is give you a bunch of questions to try on your own first. So what I want you to do is pause the video. Here's the graph of the function that we're interested in, and I'd like you to go through and try those questions that I've just revealed. So stop the video and start it again once you've had a go at all of those. Okay, let's go through the solutions. So to start with, what are the zeros of the function? Well, zeros is basically saying when is the graph crossing the x-axis? When is the value of y equal to 0? So it's going to be that point. So the 0 is x equals -5. That point, x equals -1. And that point, x equals 6. So there's the answer to part A. Now, where are the turning points on this graph? Well, a turning point basically means you're going up, then you come to a point there, and then you start to go down. So your direction has changed or turned. So that's your first turning point, -3, 2. And here you're going down, you get to this point, and then you start to go up. So that's the coordinates of the second turning point, 2 and -4. Okay, hopefully you got all of that correct so far. Let's see how you went on the next question. For what values of x is the function positive? Well, the function is the y-coordinate, so the y-coordinate is going to be positive between that point and that point, so between x is -5 and x equals -1. And it's also positive over here for all the values of x bigger than 0. And the function is negative for values of x smaller than -5. And the y-coordinate's negative, so the function's negative between x equals -1 and x equals 6. So you should have written something like that. It's positive when x is between -5 and -1, and when x is bigger than 0. It's negative when x is less than -5, and also when x is between -1 and 6. And it's 0, I should have done 0, and it's 0 at x equals -5, x equals -1, and x equals 6. So that's the values of the function being positive, negative, and 0. The next question, for what values of x is the function increasing, decreasing, and stationary? Now, the best way to think about this is think of this as being a mountain. So if someone is walking from left to right, so if the function is increasing, that means you're walking up. So the function is increasing for all of the values of x smaller than -3. That means the function is going up. At -3, it's not going up or down, so at that point it's considered to be a stationary point. Okay, the function is decreasing when you're actually walking down. We can also think of that as when the gradient is negative. So it's decreasing between x equals -3 and x equals 2. There's another stationary point at x equals 2 where it's going neither down nor up. And then once again, the function is increasing, which means you're walking uphill from x equals -2 onwards. So here's the answers you should have written down for question D. So increasing when x is smaller than -3, so this part of the graph, and when x is bigger than 2, this part of the graph, you're walking uphill. You're walking downhill between -3 and 2, so that's the way you write that. And the stationary points is when x equals -3 and x equals +2. Okay, moving on to the next question. Now we're talking about derivatives. For what values of x is the derivative positive negative, and 0. Well, a positive derivative means that the graph is going up from left to right. So it's positive for values of x smaller than negative 3. It's also positive for values of x bigger than 2. In both of those cases, you're going up, the graph is going up. Negative is between x equals negative 3 and x equals 2, which is this part of the graph, and the derivative is 0 at that stationary point, because it's not going up or down, and at that stationary point. And hopefully you realized that the answer to question E is exactly as the same as the answer to question D. So in other words, the function is increasing when the derivative is positive. The function is decreasing when the derivative is negative, and the function is stationary when derivative is 0. And that's what all of this says down here. So you might want to pause the video and read that, but pretty much it's saying question D and E are two ways of asking the same question. And therefore we have the same answers. Okay, here's the tricky question. For what values of D is the derivative of the function increasing, decreasing, and stationary? So not the function, but the derivative of the function. So I've got a little diagram hiding under here, so I'll show you that right now, and then we'll discuss this. So this is the tricky question. So when is the derivative increasing? Well, what we've got here, here's that same function, but I'm showing you the values of the derivative. So here the derivative is 3. Now it's down to 1. Now it's down to 0. Now it's down to negative 1. Now it's down to negative 4. So between that point and that point, it's basically getting smaller and smaller and smaller. So the derivative is decreasing. From 3, it's decreased down to negative 4. Okay, where is it increasing? Well, when it starts at negative 4 right there, it's gone up to 0, up to 1, up to 3, etc. So from that point onwards, the derivative is actually increasing. And there's a point just in there at negative 1/2 where it's neither increasing nor decreasing. So at that point, the derivative is basically staying constant for an instant. So the answer to this tricky question, for what values of x is the derivative increasing from x equals negative 1/2 and bigger? So x is greater than negative 1/2. Decreasing is from negative 1/2 downwards, because once again, if you start on the left, you can see the gradient m, which is the derivative, is going from 3 down to 1, down to 0, down to negative 1, down to negative 4. So the gradient's decreasing, which means the derivative is decreasing. And at that particular point there, which is called a point of inflection, that's when it's changing from decreasing to increasing, and that's at x equals negative 1/2. So that's probably a question that you want to stop and think about, because it's quite important for some work we're doing later in the videos. Okay, a function has a gradient of 0 at negative 1, negative 2, and 3, 2. The gradient is negative for values of x smaller than negative 1 and bigger than 3, and positive between negative 1 and 3. Draw a sketch of the function. So stop the video and have a go at this, and then once you've got your answer, restart the video, please. Okay, so it has zeros at negative 1, negative, a gradient of 0 at negative 1, negative 2, so that's going to be negative 1, negative 2, round about there. It's going to be stationary. The graph's going to be horizontal. Similarly, at 3, 2, it's also going to have a stationary point. Now the gradient is negative for values of x less than -1. So that basically means the graph must be coming down at that point, reaches 0 at that point, is positive between -1 and 3, and it's negative again for values of x greater than 3. So there's my sketch of the curve. Negative in that area, positive in that area, and negative just there. Okay, we're going to actually use all of this in the next video.